So here we have some problems from the 2.04 quiz. This is a composite figure in the coordinate plane. This one's made up of a rectangle and a parallelogram. And we want to know what the area is. So they're kind of giving you a hint by telling you what it's made up of. A rectangle and a parallelogram. So let's look and see if we can tell where the rectangle would be cut out. So if you sketch in that line right there, you're going to see a rectangle over here. And then you're going to see that parallelogram at the top. Now, the area of a rectangle is just length times width. So that means we need to find the length, we need to find the width. The area of a parallelogram is equal to base times height. So we need to find the base and the height of that parallelogram, and then we're going to add them up. So length times width. Now, this is where it gets a little tricky. For the rectangle, the length and width are not straight across on the grid. So we can't just count them out the easy way. For the rectangle, we're going to have to use distance formula. Just as a reminder, distance equals square root of, and we will take x2 minus x1 squared plus y2 minus y1 squared. And that's given 2 points. x1, y1, and x2, y2. So you can label these points in any order, as far as it doesn't matter which point is which, as long as you keep the x1 with the y1 and the x2 with the y2. So let's call this point right here our x1, y1. That point is at -2, -4. And then the other endpoint of the width is at 1, -3. So this will be our x1, y1. This will be our x2, y2. Now this is for the width. Then we'll do the length, which will be this side over here. Oops, x2, y2, not y1. Important to remember, always keeping the 2's and that, my pen's not letting me write there, but keep the 2's together and the 1's together. All right, so for the width of that rectangle, it's going to be square root of, and we're going to do x2, which was 1, minus x1, which is -2, so minus a -2, turned into a plus, squared, plus y2, which is -3, minus y1, which is -4, so minus a -4, turn into a big plus sign, squared. That's equal to square root of 3 squared, so 9, plus -3 plus 4 is 1 squared, so square root of 10. And notice it says don't round any side lengths, so we're going to wait till the end to do any rounding. We're going to leave everything just in square root form for now. So width is square root of 10. Now the length, we're going to do the same thing, but we'll have different x1 and y1, x2, y2. We can actually keep the same x2, y2 because it's an endpoint of the length as well. And then the other endpoint will be up here at -1, 3. All right, so we're going to use that as our x1, y1 for the length. So now we're going to plug in again. x2 is 1 minus a -1. Add up, square it, plus y2 minus y1 is -3 minus 3 squared. Square root of 2 squared is 4. And then plus -6 squared, because -3 minus 3, that's -6 squared, so 36 equals, and square root of 40, and we're just going to leave that just the same. So there's your width and your length of your rectangle. And you could have also used this and this for your width and your length, and you would have gotten the same because it's a rectangle. The distances are the same on either side. So we do length to be, I don't want to cooperate. There you go. Length to be square root of 40, what we just found for that rectangle. Width to be square root of 10. And now we're going to move to the parallelogram. The parallelogram is much easier because for a parallelogram, it's just base times height. Well, this parallelogram is positioned real nicely for us. So you can just count the squares. 1, 2, 3, 4, 5, 6 is the base times a height of, you want to drop the height from one base of the parallelogram down to the other one, forming a perpendicular line, so it's just 1. Height is 1. You don't have to find the length of that slanted side. You want to treat this like a triangle. Find that height that is perpendicular. All right, so we get square root of 400. Well, I'm not even going to write square root of 400 because square root of 400 is 20. So that works out really nicely, actually. And that's another reason to not simplify until the end, because a lot of times it works out to be nice when you multiply it all together. We multiply these, we get square root of 400, which is 20, plus 6. We get 26 units squared. And we're done. One more I want to look at. What's the area of this polygon? First, we need to think about how to divide this up. If anytime you see a rectangle or a square, you would just want to utilize that. So we have a square and then our rectangle, and then we have a triangle, this big triangle in here with a nice height that we can count. So we're going to find the area of the rectangle. Length times width, this one turns out to be nice and easy. So length times width will be for the rectangle, and then plus the area of the triangle, which is 1/2 base times height. Length times width is going to be 5 times 7. Actually, 5 is the width and 7 was the length, so we'll write it in that order. Plus 1/2 the base of this triangle. If you look at it sideways, we're going to count the base here because that's the easiest one to count. The base is 7. It's the same as the length of the rectangle. So 1/2 times 7 times a height of 2. So that's 35 plus 1/2 times 7 times 2 is 7. And we get 42 units squared, just adding up those different figures that make up the whole.